we've laid the groundwork. Now it's time to get down to business and actually make these intervals that we need. So we have our pickpocket data from before, and we need to draw a normal probability plot and box plot for these data. Now, why are those graphs necessary? Well, if you recall, that data set was only 25 large. We only had a sample size of 25. And 25, last time I looked, is not bigger than 30, right? And we don't know anywhere in here that it's normal. I mean, if they tell us it's normal to begin with, then heck, I can do 5 pickpocket offenses for all I care, right? But they didn't tell us it was normal and n is less than 30. And if we don't know it's normal and n is less than 30, then we have to have a probability plot to prove that the data is normally distributed and that there's no outliers. So the sample size was less than 30, and we were not given, quote unquote, that information that the population is normally distributed. So we need to verify that it's normally distributed. That's what this left-hand plot is for. And with no outliers. That's the right-hand plot. So are there other requirements that we've satisfied? Well, the other things that you need to have is right up here in these bullets. You need to have sample data come from a simple random sample or randomized experiment, right? So this had to be random data, and it was from the FBI records. We randomly pulled 25. The data come from a normal distribution. That's what we proved down here. That's the third bullet. And that second bullet, sample size is small. Remember, that is to prove independence. Data were from a simple random sample. Here, hold on. There we go. So yes, the data were from a simple random sample. That's the first bullet. The second bullet is that the sample size, which was 25 in our case, is less than 0.05. I could just write that. Is less than 0.05 capital N. And that's good because that ensures independence. All right. So we have those two things. Always good. All right. Now we are going to construct this interval. And it says to show the formula of substitution in the final answer. So we're going to do this a lot of ways. Now the formula, I just write the formula in this blue box. See that one right there? I write it two ways. You could write it separated like this, but honestly, I don't do that very often. What I do almost always is write just a plus or minus symbol, because that's really both sides. You get the plus side to get you the high number, the minus side to get you the low number. Now the question becomes, where do these numbers come from? So 513.32, 206. Blah, 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 all that stuff. Well, the 513.32, you can't see it right there, but it's really small in the mini tab plot. But also we can make StatCrunch help us out with this quite a bit. So we're going to go back to 9.1 example 1, or 9.2 example 1. I'm going to copy and paste these values into StatCrunch. StatCrunch is really going to be so nice. This is right here. This stuff right here is right where StatCrunch starts becoming really darn handy. Way more useful than Excel. I want to make that row just a little, or that column just a little bit wider. So let me go to columns, widths. I'm going to make this just a little bit bigger. Actually, I'll just click that. There we go. And actually, I'm also going to change my font because it's so small. I want you guys to be able to see it. Let me try 20. There we go. That's better. Oh, now I'm going to make the row column widths different again. There we go. All right, so you have those numbers in there. You go to stat, and we're going to go to T statistics right there. This is one sample because we're in chapter 9. 2 sample, by the way, will be chapter 11 when we get there, and so we'll paired. So we have data in this problem. Now, if we didn't have data, if they had just told us the mean and the standard deviation, then we'd pick summary. But they gave us a raw column of data, so I'm going to use it. So I'm going to click with data. So I tell it what column it is. So I click on that pickpocket losses. Click next. Now I'm not doing hypothesis test. That's chapter 10. I'm going to do a confidence interval. Now what kind of confidence level do we want here? 95%. Okay, so let me go back, to the Java thing. And I want to tell it 95, 0.95, next. I don't need to store it, so that's fine. Calculate. And there we go. I can copy, take that into Excel, and paste it in. Right there is your confidence interval. I'm going to double click on these to make them the right width. But there it is. Done. Simple as that. And it's just not worth it to do it in Excel, to be honest. It just isn't. Now, where do I get the t-score from? And by the way, you can see those numbers are exactly the same numbers I came up with here when I did it. So you can see them. And there's just, yeah, just do it with StatCrunch. I mean, I can't begin to tell you. StatCrunch is a breeze for this stuff. Now, the only thing is, where did I come up with these numbers? 513, 206. Like, how could I get those? Well, you can see, you know what, let me bring this output. Let me bring the whole thing over so you can see it all. Okay. Oops. So you can see that 513.32 comes right out of here, right? And then the standard error is right there. That's what this value is, 262 over 220. 262.2309 over square root of 25. That's 52. Now, could you go find those values on your own? Sure. I mean, we all know how to find standard deviation. It's equal to STDEV, parentheses, all this stuff. There we go. So there's the standard deviation. Since you need it for the formula, you might as well find it. Okay. You could also have found it with StatCrunch. Remember, we did those. That's stat, summary statistics, column. You say you want that column next, and then there's the standard deviation right there, 262.23. So you can find it with Excel or you can find it with StatCrunch. I don't really care. All right, so we've got that value right there. Now, again, if they gave it to you, then you don't even have to bother with any of that stuff. Now, where does the 2.06? That's the really tricky part, that T alpha over 2. So let's remind ourselves for just a second that alpha, I'll do it this way, alpha is equal to 0.05 because the confidence level, here, let me put it this way, your confidence level, your C level, is equal to 0.95. So alpha is the complement of that, which is 0.05. So alpha over 2 is equal to 0.05 over 2, which is 0.025. There we go. So what's our degrees of freedom? Degrees of freedom is equal to 24. It's right here. You can see it there. Or you can say, oh, there were 25 data points in this data set, so degrees of freedom is 25 n minus 1, which is 25 minus 1, which is 24. So why am I doing all of that? Well, you can find that t-score right there, 2.0639, either by using Excel or StatCrunch, right? You can make it come up with that t-score. Again, that would be stat, t statistics, oh no, sorry, stats calculators, t, and you say, I want my degrees of freedom to be 24. I want it to be a right-tailed 0.025. Ta-da, there it is, 2.063. Okay, or you can find it with t inverse, right? So the t critical value, right? You can get it from t inverse, or t dot inverse, sorry, 0.025, oh no, 0.975, comma, 24. If you did do 0.025, it's not the end of the world. It just make it negative, so equals t dot inverse 0.025, comma 24. You'll get the same number. Or, would it be even easier, like on the exams, you probably won't have, you know, Excel or StatCrunch available to you, but you have this table. So you go to the 0.025 column, drop down to 24. Oopsie, 0.025 column, right there. 2.064. See? So you, one way or another, you've got to get that t-score right there. So 2.064. Right there. You can get it out of the table. You can get it from your Excel. You can get it from StatCrunch. You can get it from wherever. The only thing you need for your technology assignment, if you're doing the online technology assignment, is this part right up here. If you don't need to bother with the critical value. We've already practiced doing that over here on this other sheet. So I'm going to assume you learned it then. So, but if you want to put it in there, knock yourself out. Maybe I'll give you a bonus point. I don't know. But you've got to know how to do this part right here from StatCrunch and just copy and paste it into your Excel. All right. Okay. So let's go back here now. Let's see if we make sure we answered that question. So it said to construct the 95% confidence interval. There's the formula. There's the substitution. That's the part we're working so hard for. Do we know how to find all these values? So we should know how to find x bar and s and n because we learned that stuff in chapter 3, right? You make, Excel do it or calculator do it, or I might just give it to you. Honestly, I usually give it to people. So then you just type those numbers in, and then you got to know how to find t. So, and make sure you can do it all sorts of different ways. On the exams, you'll just use the table to do it. But it doesn't hurt to know how to find it with Excel and stuff, because the table, you're really restricted to just these values that the table has. And that's it. And which is problematic, by the way, down here. You can see you start losing a lot of degrees of freedom. What if it was 54 degrees of freedom? The table won't do it for you, but Excel or StatCrunch would. Okay, going back. Oops, back to the notes. The next thing we need to do is interpret this interval. So what we want to say is that we are, and this is the way we always do this, we are 95% confident that blah, blah, blah. So that the true average, the true mu is the population average for all pickpocket thefts in the U.S. And you want to write out in English what this is talking about. So the average loss for pickpocket thefts in the U.S. is somewhere between $405.08 and $621.56. It's not a probability. It's not the chances of it being in there. It's that we are 95% sure, 95% confident that our interval captures the true average pickpocket loss. All right, what was the margin of error for this interval? Now remember, margin of error is the distance between the edge and the center. So this is the upper edge right here, and the center, we've got it right there. It's 513.32. It's right here as well. That's the point estimate. Okay, so to find the margin of error, you just take this upper level one minus the midpoint, right? The point estimate in the center. Or you could take that mid one, 513, and subtract away 405. That would also work. But one way or another, you're going to get 108.244. The other option is if you didn't have the interval pre-built, you could just multiply. You'd have to go find 2.064 again with either Excel or StatCrunch or the table, and then multiply it by s over n, square root of n, excuse me. But you should get the same answer. So there's two ways, know how to do both of them. If I give you the interval, then the subtraction way is totally easier, but you have to be given some stuff to be able to do it, right? If you weren't given the interval ahead of time, then you might have to be doing this way over here with the formula. Now, what would happen if we raised our confidence level, or excuse me, lowered our confidence level? How would the interval change? So if you're less certain, just think about this for a second. I'm less certain that my interval captures the mean. What's that going to mean for you? You're going to be less certain you capture the mean. Won't that mean that your interval's gotten smaller? I mean, if you're more certain you caught it, it's bigger, right? In other words, it's sort of like the size of your net, right? So you're making this interval a certain size. And if you want to be more certain you caught it, make it bigger. If you're going to be less certain, less confident, by the way, nothing else is changing. So you're lowering your confidence level, but your n and all that jazz, that's staying the same. How would the interval change? Well, it would be smaller. If you lower your confidence level, it means that the interval becomes smaller because you're less certain you caught it, right? And if you're lowering your interval, if your interval is becoming smaller, that means that your margin of error is also smaller, because remember, your interval is from low to high, and the margin of error is half of that, right? From the middle out. So here, right here, right? So if you have 95% confidence from one end to the other, then 90% confidence, which is less than that, would be smaller. It'd be, only maybe from 10 to 20 over here or something like that. Right? So lower confidence level lowers your size of your interval, and it makes it so that you have a smaller margin of error, which is what I wrote when I get to it, right here. Lower confidence, smaller interval means smaller error, smaller margin of error.